Let's look at section 4.2 and talk about the definitions of the 6 trig functions. So, we'll be looking at right triangles. So here's a right triangle. Now, the angle that you're looking at kind of defines your perspective here. So what I mean by that is that if I'm looking at this angle theta, then in reference to that angle, this side over here is going to be the opposite side. This side will be the adjacent, and then this will be the hypotenuse. The hypotenuse is always across or opposite of the right angle. Okay, now if I drew the exact same triangle, but instead I was looking at this theta up here, now in this triangle, well, the hypotenuse is still here, but since I'm looking at theta at the top angle, now this side on the bottom becomes the opposite, and this side becomes the adjacent. So the opposite side and the adjacent side depend on which acute angle you're considering. So you just got to be very careful in problems that you're clearly marking the theta that you're looking at, because that determines which is the opposite side and which is the adjacent side. Okay, so now let's talk about the definitions. The 3 that you discussed most in Algebra 2 and geometry are the sine of theta, the cosine of theta, and the tangent of theta. Now in these functions we just use 3 letters to abbreviate, so I'm going to write the full name just to the left of them. The sine function is spelled S-I-N-E. Now when we abbreviate that for shorthand, we just use S-I-N and then the theta. Cosine, spelled C-O-S-I-N-E, and tangent is phonetic. So you probably remember the definition of these functions. So it depends on the theta that you're looking at. So the sine of theta is, for the theta in question, it's just the ratio of 2 sides. It's the opposite side divided by the hypotenuse. And I'm spelling hypotenuse wrong there, I apologize. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. Now there's going to be 3 other functions that maybe you didn't talk about a lot in Algebra 2 that we will also discuss in detail here. And those are cosecant, secant, and cotangent. So CSC theta, CSC is short for cosecant. SEC, that's short for secant. And COT, that's short for cotangent. Now, these are fairly easy to remember because they're reciprocals or multiplicative inverses of the sine, the cosine, and the tangent function. So the sine of theta is opposite over hypotenuse, the opposite side divided by the hypotenuse side, lengths rather. The cosecant of theta is just hypotenuse length divided by the opposite length. So the cosecant is hypotenuse, and I'm just going to abbreviate here, divided by opposite. And I'm running out of space. Secant is the hypotenuse divided by the adjacent, and cotangent is the adjacent divided by the opposite. So if you know the sine of theta, the cosine of theta, and the tangent of theta, well then you get the cosecant, the secant, and cotangent of theta all for free, because they're just the reciprocals of the first three functions. So let's look at an example of how we could do a problem using these six functions, a typical problem. So here's an example. Let's say you're given that the cosecant of theta is 13 over 12. So I want you to find the remaining 5 trig functions of theta, and also find what theta is. And we'll do that, just a quick little refresh on the calculator of how to do that. Okay, so I'm going to draw a picture here. I'm going to draw a triangle. Put my theta right there. Now, I'm going to label the sides based on the definition of cosecant of theta. I know that the cosecant of theta is the hypotenuse over the opposite. So that means 13 must be my hypotenuse. 12 must be the length of my opposite side. Excellent. And now, since this is a right triangle, I could solve for this adjacent side. So I'll put an x there. And I can use Pythagorean Theorem. I know x squared plus 12 squared equals 13 squared. And if I solve that out, I get x equals 5. Or you could have recognized, really, that using a Pythagorean triple, that's going to be a 5, 12, 13 triangle, and just known that adjacent side was going to be 5 right away. So now once I have all this information filled in with the triangle, I can evaluate my remaining trig functions. So I know that the sine of theta, that's going to be 12 over 13. The cosine of theta is going to be adjacent over hypotenuse, 5 over 13. Tangent of theta is going to be opposite, which is 12 over adjacent, which is 5. The cosecant of theta was given, so I don't need that one. That was given. The secant of theta is hypotenuse over adjacent, 13 over 5. Notice that that's just the reciprocal of the cosine of theta. And the cotan of theta, that's going to be 5 over 12, which is the reciprocal of the tangent of theta, or you could do it by its definition of adjacent over opposite, so it would be 5 over 12. Either way. Excellent. So I've evaluated all of the other 5 trig functions just using the only information that I was given was the value of the cosecant of theta. Now in this case, I can figure out what theta is using any one of these equations, but the only 3 functions on the calculator the only 3 inverse functions are sine inverse, cosine inverse, and tan inverse. So I'll take the tan equation here. So I know that tan of theta equals 12 over 5. Now if I want to solve for theta, I need to do something to both sides that I need to get theta alone, essentially. So what I need to do is I need to evaluate both sides using the tan inverse function. So I'm going to take the tan inverse of both sides. Now when I take the tan inverse of the tan of theta, tan inverse of evaluating a function like the tangent function, but then evaluating the inverse just leaves you what you started with, which is theta. So this just leaves me with theta equals the tan inverse of 12 over 5. Now I can evaluate that using my calculator. So you just got to be careful because there's 2 answers you can get here depending on what mode you're in. So if I am in degree mode and I evaluate theta, in degree mode I should get that theta is approximately 67.380 degrees. But if you're in radian mode, it's going to tell you that theta is approximately 1.176 radians. So either answer is fine, but you just got to be aware of what mode you're in. Because a lot of times people would see the answer 1.176 and they would be thinking, oh, theta is probably bigger than that, but it's because you're most used to thinking in degrees. When 1.176 radians, well, that's a pretty big angle. It's actually 67.380 degrees. So again, we just have to get accustomed to there's different units for our angles, and there's a mode on the calculator when working in degrees. There's also a different mode if you're working in radians. So you just got to remember to to switch back and forth depending on which what you want your answer to be in.